Okay, guys, hello everyone. Thanks for joining us today. And today we'll be talking about most recent Java features. And the speaker today is Shan Hadib. He will tell us everything about features starting from Java 11. Maybe these are, well, maybe you will start working with Java 8 because it's currently most popular version of Java, but anytime any project can select to migrate to Java 11 or Java 17. They're newer, safer, faster, and well, in general, they work better. As always, I remind you that you can ask your questions in the chat. We will answer all of them. And please put your likes and write comments. It really helps us. And with it, I'm passing the word to Shinhadip.
Hello, everybody. I am Shankadeep or Shanka for short, and today I'm gonna be showing you around some mostly language features of Java, Java 11 and beyond. So if you want to fully follow along or want to check all the examples out, uh, make sure you have Java 19 because I executed all of the code and everything against Java 19. So with that, let's get started. So let's start with some basic concepts like object-oriented programming specific. Java is an object-oriented language, and people do complain about the way Java does it. And one of the things that people complain about is that you have your object hierarchy, but you can't be strict about it. Meaning, before you could have just a class or an interface. If it's public, you can basically make that your parent from anywhere, right? So what they recently introduced is something called sealed classes and interfaces. And what it essentially does is it restricts you from from just any random class or any construct down the line from making parents. So you can have sealed interfaces, abstract classes, and classes. So let's get started. For this I just use the shape const thing that you know a lot of you might probably be aware about. So I have a shape, and only ellipse, parallelogram, and triangle can basically have shape as their can implement shape. Now, ellipse, parallelogram, and triangle can also be interfaces or class or abstract classes, like I said. So let's see. Let's start with parallelogram. Now, parallelogram, you see, it's an abstract class. It is sealed, and the idea over here, the strong idea that is enforced over here is that if if you basically if you have if you have what's permits, and if the class or interface's name is in this permit, right, then you have one of three choices. It either has to be sealed, the one that's implementing or extending a sealed parent. So the child either has to be sealed, or we will look at some of the other ways in which we do it. So that's that. And we can also extend the sealing mechanism as well. So we can have seals, and if we have seals, we need to permit. This has to be there. This combination of seals and permits has to be there. And we can actually just not even have implements, but just to show you, like I've shown that you can have implements, but you can definitely not have implements and just be fine with it. It's totally fine. So just for example purposes, I basically just have this. Okay, so we can have a sealed interface or class, then that gets inherited to another class or interface, which can also be sealed, but the permits has to be there. That's the idea behind it. Now, parallelogram uh, explicitly mentions that I only want rectangle to inherit from me. and a rectangle has to be final, because at this point of time I'm saying that okay, enough of inheritance. Let's close off our inheritance cycle. So to do that, we need final. So nobody can extend rectangle. So this is the second construct that goes with sealed. So if you are inheriting from sealed classes or interfaces, you can be number one, either sealed or you can be final. And I'm coming back to the third one. And your regular OOP construct, Java construct, like chaining with the superclasses and all, it just it's there. You can do all of that, as you can see. So that's that. So let's go to Ellipse, because Ellipse is something called non-sealed. Now, what is non-sealed? Like, as you can see, non-sealed doesn't have a permits. So that's the and this is basically what I would say the chink in the strict inheritance hierarchy armor. This is where the strict inheritance hierarchy kind of breaks. And the idea is this: that let's say you have, let's say, a class or whatever interface that you have, you're not sure what kind of subclassing that you're gonna be. What can you permit? You don't know. So in that case, you can leave it as non-sealed, and when it becomes non-sealed, we are back to the old Java inheritance model. And I guess you know all about that. Uh, that is that. And what, but then again, it's a non-sealed class or interface is another just a class or an interface. So what I did is I went ahead and just normally if I don't have this seal, imagine that this is not there. So this public class circle extend ellipse, plain and simple construct. But now from here I can again start back. I can again resume the strict inheritance hierarchy, and I made it a sealed class, and that's a circle. It can permit a semicircle. Not not that properly constructed in terms of geometry, but for the sake of explanation and pedagogical reasons, I guess it should suffice. So if you look at semicircle or semicircle, it has to be final again. So we know it's sealed or it's final, and then now we are going to be coming to the the third construct, which is a record. So basically sealed, non-sealed, or record or a final. Basically, these are the things that you have to have if you're using the sealed construct, right? And record is also a new component. We are going to talk about records today as well. And what records usually do is it's basically what you call a name tuple. So you have let's say you have wondered a lot of times, right? That I have some kind of program where I just need two values, tuple a, x, and y. That's it. Nothing fancy, nothing, yeah, or anything going on. For that, I need to create, let's say, traditionally in Java, we need to create getters, setters, and all of that thing. We don't even care about it, right? And it's a lot of boilerplate that goes into it. Now, record addresses that problem. So it gives you this pretty compact kind of a way of creating something that looks like a class, but it works like an int. It is, when you create objects of type record, because record is actually a class, Java lang. When you create record objects, you have a lowered memory footprint as well. So it goes really well with collections. So if you have like a triangle, then you want to throw like this triangle instances into a list, or or into a graph. It works really well. It is much more memory efficient compared to that of if you have a class. Records are final. Uh, Point to keep in mind, they're final, and you can't even extend, you can't inherit anything from a record. You can implement from interfaces, but you can't like uh, like say let's say mm, buffer extends buffer reader. So you will have something like like this. You can't do this. Records can't inherit from state providers, which are classes or even abstract classes, but you can have interfaces. So that's records and sealed classes, and also that's how record actually fits into the sealed class ecosystem. It's final, so it naturally lands itself into the sealed classes thing. So please feel free to ask any question that you have. Be pretty nice.
Yeah, we actually have one question. Why do we need sealed classes? I think it means why do we need to restrict the inheritance of our program? Why can we need?
Why do we need to? Okay, so a lot of times, well, the best example that I can think of is, when you're learning OOP, uh, you know for sure that certain kinds of objects can only have characteristics of certain kinds of classes, or can have characteristics of certain kinds of parents. For example, when you have this animal thing, you have like an animal, and then you have what do you call uh, a duck, right? So you have like all sorts of ducks that let's say implement the animal interface. Now suddenly they throw you throw something called a rubber duck. That has nothing to do with an animal, right? So you want to restrict misuse. So in that case, you know that a rubber duck can't be an animal. There's no way on earth. I mean, it might look like an animal, but it doesn't sound like an animal. Okay, it doesn't really look like an animal, to be honest. It's inanimate. But still, you know, under the traditional uh, Java object-oriented implementation, you can still have a rubber duck as an animal. So this behavior needed to be restricted. That I only want to allow certain classes to basically inherit from me. As a superclass, I want that control. So this is why I would say that that's the reason why sealed classes came into play. That's the reason why control over your type hierarchy comes into play.
Yeah, from what I read, it becomes very useful when you develop some library, not a production code that you always have control over, but library code that you ship to someone and that person can do whatever he can with it. And when you develop a library and you restrict the classes that can inherit some of your basic class, it's easier for you to work instance of become easier, and I think switch matching becomes easier too, and maybe it will be shown later today. I'm not sure, but yeah, maybe later.
Well, you basically launched a spoiler with that. The next topic actually, which is basically switch expressions. Uh, that's true, yeah. And actually, speaking about libraries, is that this is actually true that you want to protect some of your classes and allow some. The only downside is that sometimes libraries are poorly written, and as a result you might want to customize some of the classes that as a user of the library. I want to customize some of them which have not been written properly, and I want to like really in a hurry. But that's the only counter argument if somebody forces you to like say like, why would you want to not have a strict type hierarchy in this case. But that I would totally agree with this, that as a As a code owner, I want my constructs to be used the way I want it. Not
Yeah.
like, not like the wild, wild west kind of thing, like, just extending and doing whatever you want. So that's one big reason. So, okay.
Yeah, I don't see any more questions, so we can proceed with switch expressions statements. Yeah, I will
Uh,
return later.
hmm Okay, so in traditionally what you had in Java was something like, switch, what's this, in whatever, and then case circle, and you do, let's say, something over here, and then uh, you know uh, you had a construct for something like this. Uh, shape in uh, shape okay, let's say shape, right? And then you had something like uh, shape is equal to, okay, no, not really, I don't really, okay, I was doing shape is equal to, let's say, new circle, and then circle takes in a radius, something like this, and then break, and then whatever computation that you do with the shape over here, like, right? This is traditionally what we do in Java. Pretty cluttered up. You see, you have like this variable sometimes, and then you have this variable, work with it, assign, then break. People forget breaks. Then you might also forget the default, and when you forget the default, this might be this might be null, obviously, but then you are very smart and you just did like shape, and you simply threw in some kind of dummy object, some dummy object, right? So that it's not null. That's even worse, because at least you were getting a null pointer exception, which told you that, hey, you missed something, but now you're not even getting that. So basically, bad practices all around. When in reality, you just wanted like a shape object to be assigned to this, right? In Now we have this ability, so you don't need to do this entire thing. You can just like uh, you know uh, shape is equal to okay, I have this shape. You can have this assigned directly. It's now an expression. It's no longer a statement. It's an expression that you can assign to uh, you know to a variable, or return directly from it, which was in the initial code, as you saw. And you can just, for example, why would you want to do that? Let's say I want to just log the value. Log, uh, let's say logger that, I don't care, that log, something like this. Level info, blah, blah, blah. Stuff. Let's say it's not really the best way to do things, but uh, you know, you can do something like this. You're pretty much using some SL4G or Lombok, so this construct of it Lombok, and shape is something like that, right? You can do this, and then you, let's say, return shape. So you can do things like this, but that's the thing, when you have uh, switch as an expression, these are the kind of cool things that you can do. You see, now what really gives flavor to this is this thing called pattern matching. And you might be like, well, where's pattern matching? Because in pattern matching in Java, basically a lot of people think that you have this class called pattern, and then you compile the pattern, and then you match again, and you have a matcher, and then you match the pattern against it. It's Java util thing. But no, this pattern matching over here refers to as if I provide some kind of value over here, object, whatever goes into this switch expression, it will match against possible, these cases it will match against these constructs that you provide. For example, in this enum, you will see if it's an of type circle, if it's something like this. And the thing is, you cannot, you can only have finite cases, meaning if you do this, it will cause you this kind of compile time error. Switch does not cover all possible input values. So you always have to have all possible input values covered so you don't forget something and introduce subtle bugs that that sometimes live really long and you don't even see and causes can wreak havoc. So that is a very good benefit of this kind of construct. And over here, you can see you can either just directly, if you have this one-liner, so it naturally implies that this is the return value. But if you have multiple lines like this, then you have to use this keyword called yield. Now, yield is not, I would say, it's a context-specific keyword. It's not like a keyword like a, like a data type like int or something or switch or something, but it's a context specific. So you can do something like this int. Okay, what's the spelling of yield? Y-I-E. So you can do something like this. No problem. You can have a variable called yield, but when it is used in such a context inside a pattern expression, a case, a pattern, and you want to, return the value, you use the keyword yield instead of return. Point to keep in mind is you can have return as well. There's no problem with, okay, there's a problem with the return outside and closing. Okay, yeah. Yes, this is also an important thing. Why didn't the Java engineers go for return? The reason is that return, as you know, will get out directly from the method itself. It will get out from here, the entire method itself, right? Meaning these lines, this line of code won't work. Right? So that is why they came up with a construct called yield, so that you just exit from the switch block only. That's it. You simply exit from the switch block, assign whatever the value, whatever, and then continue on with the rest of the execution in the methods. So that's the reason. And there's a lot of some videos on YouTube regarding why the name yield was selected. Why not just leave the last line just like this, like like you see in Scala or Kotlin. The last line is the return expression. But Java developers, architects, they decided to use the yield keyword to explicitly specify that yes, we are returning a value from the switch expression block. And naturally, what happens is that when it comes to instance of, this also kind of plays a part. So now what happens is that with instance of, what you do, you don't need to do all this, tedious casting and everything, your code is much clearer now. Meaning you can do stuff like this, that if given input is an instance of a particular class, then automatically assign it to this object, this reference basically.
I'm sorry to interrupt, but can we probably show an example of how it was before this feature with instance of? Could you show this cast?
Basically, you have like this shape instance of rectangle. Then you have to do something like shape sh is equal to, let's say, rectangle shape, and this is basically what we
be not shape but rectangle equals rectangle.
Well,
yeah, so it saves
so this is
a line of code.
So this is one more line of code. That is another thing. And this construct is something that that is one of the things that can be avoided. Why do I need to do it? If it is already an instance of rectangle, why do I again need to write one more line of code and start bloating it? Because this looks like a single line of code, but when you have a lot of classes floating around, a lot of POJOs floating around, especially the equals methods, this can get really big. This can add up to like really a lot of lines of code. And especially if you're writing like a monolith. Let's say you have a monolith, and monoliths have a tendency to grow, let's say a million lines of code, and you have like a 200,000 lines of POJOs, and you have just this one statement is consuming like 15,000 lines. It's one line, or 10,000 or 5,000 thousands of lines of code, right? For nothing. And that actually also, one of the things that does is also eat up code space, because when your code runs, it has to be stored somewhere in memory for it to be read, and and all of that. So this also adds to the code space that gets used up. So that's one advantage. So that's why this construct helps. Now what you can do is you can actually perform expressions on this as well, like and r dot length is equal to 10. If this rectangle is greater than a unit of 10, then it's a rectangle of length greater than 10. Nice. So that's good. But one thing to note, you can't do this. Why you cannot do OR is something that you should be thinking of about yourself. It's a very straightforward logical question. It's, I would say, homework for you. So that is something that I would say that's the benefit of this kind of matching with instance of. I think, and I'm pretty sure that they are going to refine this even more in the coming Java versions, and we might be able to see a lot more with this. So that is with pattern matching, and then with instance of and all of that. And by the way, the scope of this R is basically within this. You might think that where is this valid? So basically, if you try to access R over here, you can't do anything with that. So it's not valid outside the scope. Over here, you can do R dot whatever. So
yeah, and there is an interesting feature. If you write if not shape instance of rectangle R, then it is defined everywhere in the method except the brackets right after that if.
Yes, exactly. So if, for example, you have this, so if not shape instance of, let's say, parallelogram, if it is not, then, well, you enter over here, then yeah, parallelogram P, then let's say P dot, nope, you still have the scope somewhere over here actually. Ah, yeah, it's not actually available. So P is not, but then again, this kind of it wouldn't make much sense, because if it's not the instance, so what's the point of this? It's exactly like the OR, right? You have this OR. What's the point of R over here? No point, right? So that's the it's actually very logical. It's a very simple logical flow as to why this is.
Yeah, but I think the implementation of this feature was very difficult, calculating all these scopes. Actually, we have one more question about switch statement. Could this case return void? I think this case parallelogram and rectangle return void. It's not new rectangle. On the line 26.
So you mean to say return void as in the type void?
No, I think just comment out the line 26 and 27 here.
26, okay, 27 basically. Yeah, let's say 26, right?
Yeah.
So you need to return something, and it has to be, you're basically going, you're doing shapes, right? So obviously this has to be attached, or it has to return something. In this case, it's a shape. So void is not a shape, so it won't. I mean, because technically void itself, the way you look at void is that you get out of the function without returning a value. That's how void is thing. You get the return address, but no value assigned to it. So you just want to run a bunch of procedure, and then you want to go back to the place from where it was called. That's how void technically works. But over here, as the idea is that you have to have something returning of the of a concrete type. When I say a concrete type, I mean, like, in this case, like, let's say a shape. So you can't return
Anything
something like
else?
anything else, like, let's say a buffer reader. You can't return a buffer, for example, you read new buffer reader, blah blah blah. You can't do that. So type safety has to be the type safety rules has to be maintained. You have to this has to be type safe.
Uh,
So
yeah, so if if the switch statement returns something from the methods, it has to return the shape. But if we, let's say, remove the return here and yeah, comment out this line. Yeah, so the switch compiles, but the methods. No, we can remove this void. We just system out println something. If
it will do nothing. Basically, it will do nothing, and for this case, you basically get nothing.
yeah,
And that is that's basically a problem. That might get, because what happens is, in all likelihood, you will have something like this shape, uh, right? Yep. Now you see, you are not returning anything. So, or you can, yeah, that's what you do. Because if you don't have this, it compiles perfectly. But what is the point of this? What is it doing? And you have to return something. Let's say you return.
you can write system out println or log something in each
Mhm.
branch. So just this statement will be used to write some information to the log, not to
Mm-hmm.
return something. So I think it can be used. It will be much more like the previous
Previous switch
case
statement.
expression, yeah.
Mm-hmm.
But you don't have to write a lot of breaks, so it's more concise. And I would prefer this one really over the old one.
I guess, yeah, because especially if you know your states, if you know exactly what state your object can take, like this, like in an enum, in that case, yeah, it's perfect. But yeah, you are right. But although I would say you're kind of, you're, you're kind of misusing, a lot of language enthusiasts, they will tell you, like, hey, that's not how you're supposed to be using it, like that. They might even go to war with you. But yeah, this is a very neat use case where you don't return anything. I mean, but then again, you know, this itself looks a bit bad. The code itself looks a bit bad, because a you have a regularity. You have a fixed way of doing things, and then you're breaking that fixed way of doing things. So it depends on how you are using it. If you're doing, if all of them return nothing, then you're fine. You know what's going on. You understand the context. But if that's not the case, if even one of them is returning something, then there's a problem with the design choice over there. So yeah, that has to be kept in mind.
Yeah,
So
yeah,
default. Now
okay.
let's see. Can we do now? Not a statement. Nah. Okay, let's see.
Uh,
Let's try this. Default circle 10. Yeah, you can have a default like this as well over here.
yeah. Okay, let's probably go forward. I see two more questions that we will probably cover in the end. And
Hmm.
yeah, okay.
Okay, so moving forward into some of the, string aspect of things, because there's a lot of thing as far as I know, there's a lot of string related stuff has happened. Where is uh, yep. So strings in as you know in in Java 11, I think they introduced something called a multi-line string, and they are essentially text blocks, you know, and the good thing is that you can write things like, you know, entire JSON without actually having to, you know, concatenate your plus and, you know, put in line breaks and everything. Also, you can write SQL statements pretty well, or HTML. So, for example, I use this kind of constructs in even in my projects where we use Java 11. So in JPAQL, or yeah, basically in JPAQL, if you're writing your own statements or something, you can do that. You can also combine statements. So let's look at uh, what it actually is. So you have, as you see, you can also have in this text block, you can have these literals, escape characters, and special characters for tabs, for new lines, for breaks and spaces and everything. You can have all of that. You can put all of that in, and it will behave just like just like your usual stuff. Now, one interesting thing, at least I can tell you, is this formatted thing. So formatted is a new method that was added in like 15. So, and it applies to text blocks. So what you can do is it's helpful specifically, I would say, in a situation like this. You have SQL statements, you have, let's say, an outer query and an inner query, and you want to separately write them. This is something that you can do. This is, let's say, the inner query, and this is the outer query, and then you want your inner query to go somewhere over here, %s. You can do formatted, and you can have, you know, this like that. So you probably know string.format. So this is also, but this is specifically for, it's mostly for this things, for string blocks. That is that. And also with multi-line strings, you know, you know about trim, string.trim, which removes like leading and trailing white spaces. This thing called strip, and there are two variations, like strip leading, strip indent, stuff like that. But basically, they behave in very similar ways, in the sense that since you have this huge line of blob of text, you might want to remove some of the trailing white spaces from the front and also from the back, if you have them. Let's say, for example, like this, like a tab character. So you can do that using strip. That is pretty well done using this method. That's what it's basically. Imagine you're using trim, but instead for bigger code blocks, which would essentially be strip. So that is that. So we can look at some of the ways in which it actually kind of, you know, executes it. So yep, let me just show you real quick what it actually does. So you know what strip does, it strips the indents. Now if you notice, I have this tab spaces and tabs, you know, enabled, right? So if you notice, over here, starting you don't have, ending you don't have any character, tab character. But if I go to the string, you see you already have like tab characters. Now, one thing to keep in mind is that your indentation and everything, it starts with this. Your last, basically between your three colons, three quotes, and the ending three quotes. So whichever comes first. Usually the idea is to have the opening quotes, you know, in a position like this. You know, the name of the variable, and then you have this, and then the ending is the one with which you start your alignment. In this case, it already starts with two leading spaces. This is your constant, like this the first two, 1 2. The rest of the three, nah, not so much. But when we do trimming, when we strip them, you see the leading and the trailing, because it's a tab space, they are gone. So it's kind of like trim, but for multi-line blocks. So that's the first one. The second one is basically just you can have this formatting. See, formatting, and then also you see this backslash. This is basically like that. Basically, this backslash says, don't put it onto a new line, because if I don't put this, and then if I don't put this backslash, you will see this that it will go to the next line. So keep in mind that yeah, this xdex. Keep in mind the xdex. It will go to the next line. So if you run this again, this will go to the next line, because it's in the next line, right? You see, goes to the next line. But if you have this construct over here, it basically it stays at the same line. So that is kind of helpful in formatting, in basically organizing your text as well. That's the, I would say, second one. And the third one, I would say, at least the third one that I would say is something called escape translate. Now, to understand escape translate, we have to look at this string. So now this string, what happens is I have entered all the string literals, right? This kind of \n, \b, don't take it to the new line and everything. What escape translate does is that it takes that original string and creates an entirely new instance out of using the escapes and everything. So that's why you see the original text and the escape translated text, they are not the same instances. But if basically that's the idea. So it creates an entirely new string out of it. So that's what escape translate does for you. So it's not your original string that you have. So that is about escape translate. And another one is compact number format, which is, as you can see, if you have, let's say if you have a scenario in which you have to, let's say somebody makes a transaction or something, and then you have to convey the message in a numbers amount in a very user-friendly manner, let's say. So you can use compact number format, and you can specify the local and style short or long. I mean, and then give the amount, and it will give you like 1 million. So this is basically 1 million in short. Let's look at it in the long format. So let's see what happens in the long. If you have like 1.2 million, right? So if you do that, then it will tell you 1 million like that. And you can give your own local as well, and it will do that for you. So very good in terms of rounding off. It's pretty handy utility. And the last what I would want to say is basically this thing. I forgot what I was going to say. So okay. Transform. So this is another new feature that got added, and from Java 12. So this one is like a map. So you take a string and then you perform a map that map returns basically like a new instance. So you must have done this very basic Java exercise. You read from the console and then read some numbers and do some calculations, right? So transform allows you to do this, or else basically before what you had to do is something like uh, this, and basically integer dot parse int and something like this. But now you can just do this, or you can transform it, map it into any other construct, whatever you want to. That's up to the user. And also you can see that you have like local type inference with var, and this is going to spoil a lot of habits. Sometimes I forget, like, if I have to use an explicit type, I kind of just forget about it. But this is a very handy construct, especially when you're writing Spring programs and you have like something called like a stateful Redis connection with bunch of generics. You have to write that on the left side, and also on the assignment side, right side of the assignment. It becomes really big and looks bloated. So just write a var, and at least you save a lot of space. And it's one of my favorite features as well. Highly debated, but still makes the code look a bit compact.
Yeah, we actually had two questions about these var keywords, and if you touched it already, I think we can ask them now. Yeah, you have already answered in the first one. What do you think about these keywords? And the second one is, what do you think about programmers demanding banning usage of var in Java projects?
Well, let's if you think of it from in my opinion, the longer the line, the more my eyes have to scroll through. A lot of things that we don't realize, that it adds to physical stress, and the more your eyes are scrolling through and all, like, you're reading through, your focus might also you might also lose a bit of focus, and it might accumulate up. It's better if your code is, as compact as possible, as centralized as possible, and var is actually a good step into that direction. And this is a very opinionated answer. There's no right or wrong answer in this one, to be honest. But I speak from, I would say, basically a physical as well as a physiological and mental point of view. Because a lot of people get distracted. If I'm looking, wrong method name, I reach the end of the screen, and then basically I'm looking at the side. I'm sitting in a nice office, I have a nice view, I'm looking, nice view, enjoying the view. I'm distracted already.
Yeah, we need to get a coffee break after reading the method name.
So yeah, so that's why var is a good step in that direction, I would say.
Yeah, I'd like to add, I personally don't like things like var I equals 1, var b equals I plus 1. So here you can replace var with integers and the line will be short too. But there are a lot of jokes about class names in Spring, like manager, connector, and 15 more words in the name of the class. And if you have to write them on the left side, the name of the variable equals new, and the same 15 words on the right side is just a lot. And here var really helps, and it also is really handy in tests because, well, the code quality isn't that great in tests, and well, it helps to save a lot of time typing it and reading it. So I don't like the idea of banning this word, but also overusing it is not the best practice, as for me.
I totally agree with you. Exactly my point. That if you're using some small counter and stuff, then that's fine. And if you're, because most of the time your code is not like this two words. This integer parse will be like this, and then you have like 100 lines of code, And then again, somewhere you're using this integer parts. Either you name it really well, which conveys what type it is, or you use it like in the very vicinity of your visual range, that you can just directly look and in 2 3 lines you're using it, so you know what it is. But yeah, the focus should be the main point should be to write the code in such a way that your focus is retained. You're not distracted, as well as you don't have to look around for things and by forgetting things. So yeah, that's it's a mixed bag. So yeah, you have to be careful with this. And I think the JP page for or the Java specification something the process page for this basically has like I think 10 pages of how to use var, but it's kind of ridiculous. But yeah, that's kind of how it is. So that's with string utils, and I guess there is. Where is it? So in collections, there are some of the things that have come out, which is, for example, before you had you needed some kind of construct to when you're collecting, especially when you're collecting. So when you're collecting things, you had to do like something like dot collect collectors or toList. You had to do this kind of things, right? But nowadays you don't need to do this. You can just do dot to list. That's it. And this toList, the good thing about this toList, what I really like, is that it's an unmodifiable list. Because collectors.tool, when you did this collect and this one says nothing about there is no guarantee on the type of mutabilities. Mutability. Forget about serializable and thread safety. We don't care, but mutability, at least you basically don't have any guarantee about that. And a lot of times, when you're doing this kind of stream operations, whatever you return from here, whatever you get from here, you start consuming. You throw it somewhere and you don't modify it. Most of the time, that is how you should be doing things. If you're following like a functional approach to programming. So so if you're using, for example, toList, this really helps in that aspect. So you can easily, and this is arguably the most popular construct there is, like just make a list, and this helps you to stay in, not too much, modify the list or something like that. So that's one construct, and then there is another construct called map multi. Now map multi, to be honest, even me, I'm a bit confused regarding how exactly this works and where can I use it without making it complicated, because as the documentation says that it returns a stream consisting of the results of replacing each element of the string with multiple elements. So for example, you have like a list of lists, right? Pretty simple concept. So instead of this 1, 2 as a single element, which is a list, I want like 1 and 2. So you by default you are like, it's flattened. It's like, why don't we use flat map? It's just a pretty simple case of flat map. But I would say you can use this multi-map when you don't want to create a stream inside a stream, because for flat map to use, you have to have this as a stream. So that's the idea. You have to again stream from this, and that's, you don't want to create multiple streams. So multi-map, what it does is that it kind of gives you a way to unfold objects, but it's kind of complicated. So this is right out of the documentation. I mean, if you look at the documentation, it will have this example right over here, just to this thing. And this consumer object is basically the way you insert multiple objects, multiple elements for that single element that you have. That's basically how you kind of do it. So yeah, it basically just prints 1, 2, 3, 4, 5, 6, 7, 8, 9 as a single list. But then uh, another thing is that if you look at it, it's a list of list of list. You know, this one. In this case, you will have problems with flat map because flat map, it will expect all of this to be of the same structure. All of this to be of the same structure, but this, the last one, is not of the same structure of the previous three. So that's why it will be pretty useful, because this consumer now decides the fate and how to unfold or deal with the elements. So these are the two interesting things that I found. But the two lists would be the most popular thing. And by the way, you can also create something like this, a record, and internally as a private const inside a method, and you can use this record to do some intermediate calculation and then get out of and then again map it back to some other construct. So this is a very interesting feature. I really like this feature actually. So yeah, so you can do these kinds of things to do transformations and stuff like that. So that is that. What else do I have? Yeah, so another interesting feature is the HTTP client, HTTP 2 client that came out. But first things first, this is kind of low level-ish. So when I say low level-ish, it's more like an OKHTTP kind of thing. If you have used OKHTTP, constructing requests by hand, that's how they kind of do it. So you basically create an HTTP request with a builder. It's pretty straightforward. Get is created like this. Builder, put in a URI, get method, and if you want to have post, you can have post, but post would require something called a body publisher. So it's a HTTP request has an inner class, which static inner class, and that gives you a bunch of body publishers. Basically, there are there's a string, in the string type, there's a byte array type, and there's an input stream type. Three types of data supplier, and you get out of and you can extract data out of that like that. Meaning, for example, this body publisher, if I have to go into detail, it can get, it can supply data as a byte array or as a file. File is a file, but internally it uses input stream or an input stream, or it can do a string. And string would be mostly if you're making typical REST calls, JSON. The payload would be your JSON. So all of that you have to take care of it. Also, and also serialize the, writing to converting to JSON string, and then you get the response. This is also in raw JSON string. So then you have to also, parse it in in object mapper, object mapper dot read, the drill, how this is done. Right. So this is kind of how you use this. It's a low level thing. You can use it for prototyping. Very good for prototyping, but not. I wouldn't recommend this for anything in production code or something, or at best unit test. That's it. Because it doesn't give you a lot of features that you want, like rich proxying, retrial mechanism, something like that. Client-side load balancing. You don't get any of that. So you're better off using Hystrix or Feign or Retrofit if you want declarative clients. So yeah, that's pretty much it. But this thing pretty good for prototyping. So I guess that's about it from my side.
Okay, thanks a lot. I will give guys a few minutes to post their questions. Yeah, I just wanted to add on that topic that a lot of new methods were introduced. For example, string dot repeat. I think it was introduced in
Mm-hmm.
Java 11. So we don't have obviously time to go through all the changes, but well, you can go through them by yourself or just see what methods, classes that you use, they now provide. Because, for example, this string.repeat method, it works. I measured it was like 4 times faster than using string builder and doing it manually.
Mm-hmm.
Methods provided by the GDK, they're well optimized, and if you can, it's better to use them. And yeah, minutes of commercial. As always, I want to remind you that we have a free Java Online school from the very basics up to the modern frameworks, clouds, ICD, etc. And you can go to mjc.school and enroll for free today or tomorrow, but better today. Okay, I don't see any more questions, so we will be wrapping up. Thanks a lot, Shankha. Hope to see
Mm-hmm.
you here again one day.
Thanks, everybody.
Yeah, guys, see you the next week. Thank you again, and bye.